All right, welcome back to the night class. Going over Chapter 8 review today. That's vectors. It's going to be a lot of fun. Okay, right here, if you haven't changed yours, the people that just got the review, because you're absent, that should be 100 Newton force right there. So change that for me. On all of these, okay, every single one of them, you have to get your vector, okay? And there's two vectors. There's a force 1 vector, and there's a force 2 vector, okay? If you haven't remembered, x is r cosine of theta, and y is r sine of theta. Okay, and on number 1, it says a 150 Newton force and a 100 Newton force act on the same object. The angle between the forces measures 90 degrees. Find the magnitude of the resultant force and the angle between the resultant force and the 100 Newton force. So, first off, our angles. It actually doesn't give each individual angle. It just says between them there's how much? 90. So I'm just going to let one be 0 and one be 90. Okay? It makes it easier to make your forces. You don't actually have to do the r cosine. You don't have to do all that. Okay? The one that's going up at 90 will be your y, and the one that's going at 0 will be your x. Does that make sense? Okay? So these forces, I don't actually have to use all of this. I already know what they are. So it's 150 Newton force. We'll let that one be the one going 90. And we'll let the 100 one be going 0. That makes sense? Okay? So that one's going 90 degrees. That means that one is 0, 150. Okay? And the other force is 100. It's 100, 0. Again, because it's going x direction. Okay? So it's going 100 towards the x and nothing up and down. The first force is going nothing left and right, but up 150. Okay? And then you find the magnitude of that. Okay? You know, I take that back. First you do what with the two forces? Combine them. How? Add them together. Okay? So F1 plus F2, that's going to be my final force. So this one, again, it's pretty easy. It's just 100 and 150. Everybody with me so far? That is your final total force vector, okay? That is your resultant force. That is what you're going to find the magnitude of, okay? So, I'll come over here. The magnitude of your force vector will be the square root of the x part, which was 100 squared, plus the y part, which was 150 squared. And if you put that in your calculator, you get the square root. We can just round these. Rounded to the nearest hundredth, you get 180. It's not right. Okay. 180.28. And those were being measured in newtons. Okay. For your theta, should have wrote this up here, but I'll write it here. Theta is always the inverse tan of y over x. Okay? Yes, sir. This is finding the angle, the direction. So what was the y part of my vector? 150. And what is the x part of my vector? 100. So it's just the inverse tangent of 150 over 100. So theta will be, put that in your calculator, 56.31 degrees. You do need to make sure your calculator is in degree mode. Otherwise, it might not give you 51.31. Okay? Any questions? Am I good? Okay. Number 2. All right, this time, same process. What is the magnitude and direction of the resultant of 125 Newton force along the x-axis and a 140 Newton force at an angle of 7 degrees to one another? Okay, so this one is not just going up and down and left and right. We do have one that's going which one? Which way?
On the X.
On the x-axis. So it's going towards the right. Okay, we got one that's easy to write like this. But the other one, we're going to have to use our cosine, our sine stuff. Okay? All right. There we go. So I'm going to scroll, if it lets me, over here. Because this is going to be kind of big. Okay? So we'll let force 1 be the one that's on the x-axis. How many newtons was it? 125, comma 0. And the second force is going to be a little harder. It's, what's that, 140 Newton at 70 degrees. So what's the x part of that? 100 what?
140.
No. Oh, yes, you're right. I'm sorry. 140 times the what? Cosine of 70, comma, and what's the y part? 140 sine of 70. Okay?
Why can't you just use 0?
Because it's not at 0 degrees. It's at what degrees? 70 degrees. Okay? Unless it's going up and down or left and right, you've got to use your r cosine theta, r sine theta. Okay? Again, this is my x part. That's my y part, ma'am.
The last one.
Because there were, how many degrees were between them? 90. So we just said 1, 0, 1, 90. Does that make sense? Okay. I am going to leave it like that. Okay. I'm going to do what with these two? Add them up. Okay. So let me erase that x because I don't want you thinking that's a times. I am going to add these two. Now, don't actually add them, okay? It's a little more work, but I'm just going to write them out the way they are, okay? So my final vector for the force is going to be 125 plus 140 cosine of 70, okay? And then 0 plus 140 sine of 70. So I just get to leave that one as 140 sine of 70. And again, I'm adding x's to x's and y's to y's. Everybody good? Okay. There's my force. And now you find the magnitude of it. Please be careful putting all this in your calculator. When you put this in your calculator, you're probably going to have to add a second parentheses after that 70, okay? Because the calculator is going to open one up for you. Plus 140 sine of 70 degrees squared as well.
14.
I sent it to you. Oh, thank you. All right. You put all that in your calculator. That square root, I don't need to. Oops. What should you get? 217.25. And again, Again, that is newtons. Okay. Theta, find the same way. The inverse tangent of y over x. What was y on our problem? 140 what? 140 sine of 70 divided by what is our x on this problem? 125 plus 140 cosine of 7. That should equal, if you put it in your calculator right, 37.27 degrees. Okay, and please double check me because I didn't get this out of a book. I actually did the work. Okay, so I definitely could have messed up. That's a lot of parentheses and stuff. So it's a lot of room for error. Everybody good? I think. Oh, well, you sit up. How far up? Is that good? You what? So. All right, number 3, more of the same. Y'all got the problem right there in front of you, so I'm not going to scroll back over. 3, it says we have find the magnitude and direction of the resultant of two forces of 200 pounds and 600 pounds at angles of 35 degrees and 230 degrees with the x-axis, respectively. All right. Say it again. What did I say?
600.
I said 600? Thank you. 60 pounds. My bad. 200 pounds and 60 pounds at angles of 35 degrees and 230 degrees. So, God bless you. Force 1. Let's see here. The 200 pounds with which angle? 35. So, 200 cosine of 35. 200 sine of 35. Force 2 was 60 pounds at what? 230 degrees. So, 60 cosine of 230. I don't know what I was writing there. And 60 sine of 230 degrees. Okay? What do I do with those? Add them up. Now, if you're like me, I tried to do it on the actual sheet. That was a bad idea. You don't have room. Okay? But I am going to skip a little step here. As Rhett just mentioned, they don't actually ask you what is the vector. Okay? They don't actually ask you that. So I'm not going to write that down here. I'm going to go straight to figuring out what the magnitude is. Okay? So let me know if I'm losing you. Okay? But I'm just going to go ahead and write my magnitude here. Okay? It's going to be the square root, and it's a really big square root. Okay? These two added together squared, right? this one, and this one added together would be 200 cosine 35 degrees plus 60 cosine of 230 degrees. And all of that is what? Squared. Remember, it's just like the Pythagorean theorem, okay? Or the distance formula. Plus 200 sine of 35 degrees plus 60 sine of 230 degrees. Okay? Does everybody understand the step I'm skipping? I'm just skipping writing this as a vector. Okay? Because it doesn't ask what's the vector. So we really don't need to know what that is. I forgot my square, didn't I? Thank you. Alright. Put all of that in your calculator very carefully. Because it is quite a lot of buttons to push. You should get 142.89, and this was in pounds, right? 142.89 pounds. All right. Please let me know if that's not what you got. All right. Theta. The inverse tan of y over x. What is y in our problem? The ones with the signs, right? So 200 sine of 35 plus 60 sine of 230 divided by 200 cosine of 35 plus 60 cosine of 230. All right. You put that in your calculator, you should get 28.76 is what I got as well. All right. Moving on. Number 4. 4 was a little different. Why was 4 different?
3 forces.
3 forces. Oh, gracious. What are we doing, Coach? All right. So, force 1 said it was 80 pounds at what? 330 degrees. So, that's going to be 80 cosine of 330 degrees, comma, 80 sine of 330 degrees. Force 2 was 50 pounds at 45 degrees, right? So 50 cosine of 45 degrees and 50 sine of 45 degrees. That will make my x and y element of that force. And force 3, we're going to get, let's see here, 70 pounds at 135 degrees. So 70 pounds cosine of 135, 70 sine of 135. And what do I do with all those vectors? Add all 3 of them. We can't skip it, but we're going to skip where we write it. Okay? So I'm going to go ahead and go straight to my magnitude. I'm just going to add, I was writing with my paper. Did y'all see that? Look at that. For those of you viewing at home, I'm writing with my paper right now. Okay. Now I got to erase it. Can I erase it with my paper? Hey, I can erase it. I have a new board.
The magic slice of paper.
It's magic slice. Good job. All right. So we're going to add all of that. Please be very careful your parentheses. All right, so we're going to have force 1 was 80 cosine of 330 plus 50 cosine of 45 degrees plus 70 cosine of 135 degrees squared plus the y parts. So 80 sine of 330 plus 50 sine of 45 plus 70 sine of 135 squared. You could, if you so choose to, because all of these are the hand angles, okay? Like 30's reference angle is, or 330's reference angle is 30, 45 is its own reference angle, and 135 reference angle would be 45 as well? No. Is it?
Mm-hmm. Yes.
Anyway.
90 plus 45.
Yeah, that's right. Okay, so you could do on your hand, but just use your calculator. Just make sure you put your stuff in correctly. If you put all that in, you should get out 71.08. And again, we were doing pounds. Okay? That's what I got anyway. Anybody not get that? You didn't get that? That's what you got too?
71?
71.08. And there's some other numbers, but I rounded.
Zero.
Okay. Everybody's good? All right. For theta, inverse tan of all of this over the cosine part. So y
Equals.
is 80 sine 330 plus 50 sine of 45 plus 70 sine of 135 divided by 80 cosine of 330 plus 50 sine of 45 plus 70 sine of 135. Oh, it is. Did I shoot. Thank you. Yeah, these two should be what? These two should be cosine. Sorry about that. I started out right. I just didn't do it on all three of them. Let's try that again. This should be cosine. Oh, shoot. I don't want to go back and just make the eraser. Oh, my goodness.
Is it
I need to read this.
technical difficulties?
We interrupt this regularly scheduled program for technical difficulties because the teacher can't erase. Okay, let's try this one more.
It's a new board, you're still learning.
New board, still learning. We'll go with that. Okay. 50 cosine 70 cosine. There we go. Okay.
I didn't know.
Theta is, hopefully everyone got 39.13 degrees. Good job, Emma. You only got one of those, thank goodness. Dang, 3/4 vectors. And understand, there's four forces, 5 forces, 6 forces, however many forces, you do it all the same way. Yes, ma'am. You're good? You're giving thumbs up? Awesome.
Oh gosh, I thought we were doing this.
All right, one more, and we're done.
This is three of them.
I thought we were done because I had to go down right here.
Number 5. Oh, 5 has 3 forces too?
Yes.
Dang, I thought we just had one. Oh well.
They're probably not producing.
5.
Technically, you only know 2.
You just have to find the third one.
Pretty sure.
Alright.
Number 5, a 43 Newton force acting 60 degrees above the horizontal, and a second 43 Newton force acting 120 degrees above the horizontal act concurrently on a point. What is the magnitude and direction of a third force that produces equilibrium? There's only 2 forces here.
But you gotta find the third force.
Wait, that's what we've been doing the whole time. Finding the third. That's the resultant. Is the third force when you add those 2 forces together. Okay. Now there is a little difference. We're talking about equilibrium here. That's the what I explained using the hanger here. Okay. There's a force that's pulling this down called gravity, and there's forces on these strings that it's hanging on that's keeping it up, and those forces have to be what? Equal. Because if one's bigger than the other, it's going to be going in that direction. You got me? So same process here. Okay. We have what was a 43 Newton force at 60 degrees, and another 43 Newton force at 120 degrees. So this is going to be 43 cosine 60. 43 sine 60, okay? And our second force, 43 cosine 120, and 43 sine of 120. And just like last time, we're going to add those up to get our magnitude of the resultant. Okay, so 43 cosine of 60 plus 43 again, almost 43 cosine of 120 squared plus 43 sine of 60 plus 43 sine of 120 squared. All right. Put all that in your calculator, and we will have our magnitude. You should get, or what I got was 74.48. And what's the? We'll get to that in just a second. What was our newtons? I was trying to figure out our units. Okay, 74.48 newtons for your angle. Here's where this problem is different than all the other 4. Okay, it's not asking what direction does it need to go in, or what direction is the resulting force going in. It's asking what is the resultant, the equilibrium force going in. Okay, so we had this problem on our homework where the newtons were exactly the same. It's just we're going at 60 degrees and 120. Okay, so if the forces are the same, they're just going in opposite direction or different directions. What direction are they going in once they combine? What do we do with this 60 and 120? Add them, and then do what? Divide by 2. Okay, which would be what? 90. So the resultant force is going in 90 degrees, so it's going up. That's why you got undefined, okay, when you did your tangent, inverse tangent. But we don't actually have to do that on this one because the forces are the same and we can just average the angles. Okay? Now, the second problem with this is we don't want it going 90. We want a direction that's going to counteract that. So what would the counteraction to 90 be? 270 is our actual angle because we are finding the magnitude and direction of that equilibrium force that's just going to keep it hanging. Is that making sense? Okay.
Sure.
The rest
Perfect.
of them should be easy.
The rest of them are a piece of cake. We're going to do them real quick. Chocolate cake, too, is the best. Chocolate, no chocolate. With chocolate sprinkles. And chocolate morsels.
You're just
inside
making
the
this
cake.
sound better.
Kind of hungry. Okay.
I love like anything that's like quadruple chocolate.
Yeah. Like,
There's never such thing as too much chocolate.
exactly. That's what, yes. There's none.
They have just can't eat.
Well, I mean, if you're drinking gallons of it, yeah.
I just can't have too many sweets and
I think I
Say,
can
but
drink a
one
gallon of
piece
chocolate milk.
of
All right.
frosting.
Number 6. Y'all done got me.
My so weird, but I like eating
Okay.
brownies with Doritos.
It's like filling. You got more chocolate. It's like stacked. It's like a Big Mac of chocolate. I mean, I did too. That's
All right. 6 says, write the ordered pair that represents vector CD, then find the magnitude of vector CD. So, the ordered pair, all we're going to do, again, we did the hardest problems first. Okay, 1 through 5 is the hardest ones on the test. These are back to basics, okay? How would I make my vector? What do I do with these 2 points? Subtract them. I subtract the D point minus the C point. So 8 minus 3, comma, 16 minus 4. That is 5, 12.
Hey, on the test, do we have to write out how we're subtracting them, or can we just write 5 to it?
That's fine, but just make sure you, when you get the magnitude, you put plug it in. Okay. Everybody good? For my magnitude, we do not have to find the direction of these. We just have to find the magnitude. That's going to be 5 squared plus 12 squared. The square root of that, which is 13. Exactly. Okay? Everybody good on 6? All right. Number 7. 7, what's our points?
5 minus negative 1, 9, and 5, 9.
So it's negative 1, 9, and 5, 13. So we're going to subtract what?
5 minus negative 1.
5 minus negative 1, and 13 minus 9. So that will equal 6 and 4. Please don't put parentheses. Make sure you put your little vector symbols, okay? Magnitude of this, square root of 6 squared plus 4 squared. I got the square root of 52. These are the ones they want you to write it as a simplified radical. So we'll do this real quick. 2 will go into 52 how many times? 26. Will 2 go into 26? Yes. How many times? Will anything go into 13? No. So we have a pair of 2's. It comes out front, and we have a 13 left under the radical. So 2 square root of 13.
So that's our final.
That's your final magnitude, yeah. Okay? First 5 you get to round. The rest of them you need to write in radical form, okay?
I didn't know that. So
Number 8. Vector CD. C is 3, negative 2, and D is 1, 0. So, for vector CD, we're going to have 1 minus 3 and 10 minus a negative 2. What is 1 minus 3? Negative 2. 10 minus a negative 2 is 12. So negative 2, 12 would be your vector. And then for your magnitude, the square root of negative 2 squared plus 12 squared. That is the square root of 148. Well, can you reduce 148? Yep, 2 will go into that how many times? 74 times. 2 will also go into that. 37. Will anything go into 37? No. So we have a pair of 2's. Bring 1 out front. And 37 is left under the wrap. Number 9. We'll change the pace here. It says U equals V plus W. Now, in the question that's on the paper, it tells you vector V and it tells you vector W. All you have to do is what? Plug them in. And I should put vector signs above them, but on your paper I didn't know how to do that on the computer. So, sorry about that. So vector U will be, what was vector V? 3, negative 4, plus, what is W? 3, negative 1.
6, negative 5.
All you do is add the parts. 3 plus 3 is 6, negative 4, negative 1 make negative 5. And we don't have to find the magnitudes on 9, 10, and 11. Everybody good on 9? Number 10. Same process, but instead of adding V and W, what are we doing? Subtracting them, right? So vector U equals vector V minus vector W. V, once again, was 3, negative 4. Minus W is 3, negative 1. So what is 3 minus 3? 0. And what is negative 4 minus a negative 1? Negative 3. The negatives cancel, make them plus, okay? Negative 4 plus 1 is negative 3. Okay? (11) says vector U equals 3 times vector V plus 2 times vector W. A little more work to this one. Plug them in. 3 times, again, vector V one more time was 3, negative 4. Plus 2 times vector W, which was 3, negative 1. So, a little work to show on this one. 3 times 3 is what? 9. 3 times negative 4 is negative 12. Plus 2 times 3 is 6. 2 times negative 1 is negative 2. And now we add those up. What does that give us? 9 plus 6 is 15. Negative 12 and negative 2 is negative 14. Okay. Any questions on 6, 7, 8, 9, 10, 11? All right. 12, 13, 14, 15, 16 are just like the ones we just did, only there are 3 dimensions, okay? There's an X, a Y, and a Z. Everything else is the same there, all right? So, we do...
Teacher, sorry for the interruption. I just have a quick announcement. If you have Mr. McMillan or Ms. Peterson for a second block, you're going to be reporting to Coach Brewer in the gym. So, Ms. Peterson and Mr. McMillan, second block, you're going to be reporting to Coach Brewer in the gym.
Okay, so like I said, they're wanting us to find vector EF from these 2 points, okay? You do it the same way. F minus E, okay? So 7 minus 3, negative 1 minus 0, and 2 minus 5. What's 7 minus 3? 4. Negative 1 minus 0 is negative 1. 2 minus 5, negative 3. There is our vector. Then to get the magnitude of that big vector, we take the square root of 4 squared plus negative 1 squared plus negative 3 squared. And we get the square root of, what is all that? 26. Which can be not simplified.
You can mess up on this so easy.
I know, it's so simple it takes.
Okay? 26 would reduce to 2 and 13, and neither one of those repeat. So you just leave it as 26. All right. Everybody good on 12? Okay, I'm just going to scroll it up a little bit. So I can start writing 13. Is that good? 13E is 10, 9, 6. And F is 0, 6,
12.
and 12. Sam, you good on that other one?
Oh, yeah.
Okay.
0 minus 10.
All right. So, vector EF will be 0 minus 10, 6 minus 9, 12 minus 6. So that's negative 10, negative 3, and 6.
You put it to
So the magnitude will be the square root of negative 10 squared
plus negative 3 squared.
plus negative 3 squared plus 6 squared. I got for that 145.
Yep.
And I tried to reduce that
For 5.
with 5, and that got me 4 and 29, I think. Is that right? And or 5 and 29. I said 4 and 29. 5 and 29. And nothing goes into 29. So did anything repeat? Nope. So I just leave it square root of 145. Okay? $14. E is negative 3, negative 2, 1. F is 3, 0, 8. And again, these are points, and I'm making the vector. So that's 3 minus negative 3, 0 minus negative 2, 8 minus 1. So 6, 2, and what'd you say, 7? That is correct. Then to get the magnitude, take the square root of all that squared, add it together. So 6 squared plus 2 squared plus 7 squared. That should be a square. There we go. I got 89, which also looks like it can be divided by something, but it can't. 89, it's not divisible by 3, so you just leave it as square root of 89. Everybody good? It's good, because we run out of time. 15. We're back to finding vector u again. So vector u for 15 is 2 times vector v minus 5. I wrote that wrong, didn't I? That should be w.
Yes.
2 vector w minus 5 vector v. Again,
Yeah, that messed me up.
on your paper, they give you w and they give you v. You just have to plug it in. So on your paper, w is 506. Minus 5.
Yep.
V is 0, 8, negative 3. They didn't give it to you backwards. They wrote W instead of before the V.
Yeah.
Okay. Yeah.
Yeah.
All right. So that's going to be 10, 0, and 12. And again, all we're doing is distributing, right? Plus 0, negative 40, and 15. Now, you can leave it minus and just distribute the 5. I like distributing the negative 5, and you don't have to worry about minus negatives or anything like that. So, what's 10 plus 0? 10. 0 plus negative 40 is negative 40. And 12 plus 15 is 27. Everybody good on 15?
Yeah.
All right.
16.
Let me grab it. There it goes.
Oh my gosh, I wish I took my last semester. Wow.
16. Vector u equals 0.25 vector v plus 0.4 vector w. Vector v again is 0, 8, negative 3 plus 0.4 times vector w is 506.
That equals 0 to
0.25 of 0 is 0. 0.25 of 8
it's 2.
is 2. And 0.25 of negative 3 is negative 0.75. Plus 0.4 of 5 is also 2.
0.
0.4 of 0 is 0. And 0.4 of 6 is 2.4. So my final answer is 0 plus 2 is 2. And 2 plus 0 is also 2. And negative 0.75 plus 2.4 is 1.65.
Right. It's expensive. That's what it is.
17, 18, 19, and 20. Oh, goodness. We are finding the
That makes sense.
inner product. What's the inner product also called? The dot product, because it's got that dot in between them. Okay? So, please, this stuff's easy, but it's real easy to get adding, subtracting confused. Okay? When you're doing the dot product, you are multiplying 6 times -1 plus 0 times 7. Okay? And you are getting one number for your answer. Write the number. Okay? What is -6 plus 0? -6. It also asks, state whether the vectors are perpendicular. They are perpendicular if your inner product is what?
0.
Was my inner product 0?
No.
No. So my answer is no. They are not perpendicular. 18, same process. -8, 2, dot product with 4.5 and 18. So that's -8 times 4.5 plus 2 times 18. That gives you 0. And since my inner product is 0, are the vectors perpendicular? Yes. -19, -2, 4, and 8. Dot product or inner product, 16, 4, and 2. It is different, but only because there's how many?
3.
3 of them. It's not different in how you work it. Okay? Work it the same way. So that's going to be -2 times 16 plus 4 times 4 plus 8 times 2. That does give you 0.
Yes.
So they are perpendicular. Okay? 20, same process. 3, 0, 5. Dot product with 7, -1, and 2. So that will be 3 times 7. Plus 0 times -1 plus 5 times 2.
10.
3 times 7 is 21, plus 0 is 21, plus 10 is
31.
31, so that is no. Okay? Any questions on the inner product? All right, 2 more.
Kind of done though.
Cross product. That is the matrix one. Okay? We're doing 1, -3, 2, cross product with -2, 1, and -5. We'll have IJK 1, -3, 2, -2, 1, and -5.
The video and me.
Alright, so we're going to say I vector I times, and we're just finding the determinant here. You take out vector I's column, and you're left with -3, 2, and 1, negative 5, minus j, that's important, you always subtract the second one, times, you take out j's column over here, all right, if you take that out like that, then you're left with 1, 2, negative 2, and negative 5, plus k. You take out k's column, you're left with 1, negative 3, and negative 2, 1. Alright, and then you do your determinant of the 2 by 2 matrix. So that's going to be I. This would be 3 times negative 5 is 15, minus 2 times 1 is 2, minus j. 1 times negative 5 is negative 5, minus 2 times negative 2 is negative 4, plus k. 1 times 1 is 1, minus negative 2 times negative 3 is 6. And then you simplify that. So this will be vector 13. This is negative 1 inside here, but there's a negative out front. So a negative and a negative make a positive 1. And then 1 minus 6 is negative 5. Okay?
Okay.
Awesome. All right. We do. All right. So we have to take our answer and verify that it is perpendicular to our first 2 vectors. And you verify something is perpendicular by doing the dot product. So that's going to be our answer, 13, 1, negative 5, with the inner product of 1, negative 3, and 2. And we'll have 13 times 1 plus 1 times negative 3 plus negative 5 times 2. And that should equal 0. And it does. And if it doesn't, something's wrong. Probably. Our other problem, do the inner product with the other vector, negative 2, 1, negative 5. That will be 13 times negative 2 plus 1 times 1 plus negative 5 times negative 5. That also equals 0. So they both checked out. Great? Awesome.
Amazing.
Last problem. One more of these. 22. It's the cross product of 6, 2, and 10. Cross product with 4, 1, and 9. All right, so same process. I, J, K. Make your matrix. I, J, K, 6, 2, and 10, 4, 1, and 9. We're going to have I times the matrix minus J times the matrix plus K times a 2 by 2 matrix. And we plug them in. So if I take out I's column, I'm left with 2, 10, 1, and 9. If I take out J's column, I'm left with 6, 10, 4, and 9. And if I take out K's column, I'm left with 6, 2, and 4, 1. Work those out. I times 2 times 9 is 18, minus 10 times 1 is 10, minus j, 6 times 9 is 54, minus 10 times 4 is 40, plus k, 6 times 1 is 6, minus 2 times 4 is 8. So, my vector will be 8, negative 14. I get 14 here, but it's negative out, it's negative j. So negative 14, and then negative 2. So that's my answer. Then you verify it using your inner product. So, 8, negative 14, negative 2. Inner product with the first vector in the question was 6, 2, and 10. And it has to work for both of them. So 8, negative 14, negative 2. Dot product with the second vector was 4, 1, and 9. So let's see how we do here. 8 times 6 is 48, plus negative 14 times 2 plus negative 2 times 10. That's negative 28, and negative 20 make negative 48, so that would be 0. So that checks out. Second one, 8 times 4 is 32, plus negative 14 times 1, plus 2 times 9. Right? Oh, it should be negative 2 times. Plus negative 2 times 9. Alright, so that's 32 minus 14 minus 18. That makes 0. Alright. Hope this video helped. Y'all have a great day. See you next time, and as always, stay above the line.